All right, now we're going to look at how to calculate the mean and the standard deviation when we have a binomial distribution. Unlike a regular discrete probability distribution, the mean and standard deviation for binomials are much simpler to calculate. It works out really well. You can still use the same formulas, but it works out to these formulas that I'm going to give you here in a minute. But before I do that, I have some important notation to go through. So the first thing is p. Anytime we see a lowercase p when talking about a binomial, that represents the probability of success. So if I go back to my coin flip example, the probability that I get heads on a coin flip would be represented by p. So that would be 0.5 because the probability of getting heads is 0.5. N is the number of trials. So if I'm going to flip the coin 10 times, that would be the number of trials, my 10 coin flips. And then X is the number of successes. How many times did I get heads when I flipped the coin 10 times? That's represented by X. So the formula for the mean of a binomial distribution is as followed. Mu equals the number of trials times the probability of success. Okay, you could also write this as N times P. But having the two letters next to each other, that implies multiplication. Okay, so I'll put that in parentheses. But if you want to see the multiplication symbol in between to remind yourself that you're doing multiplication, that's fine. So to find the mean, we just take the number of trials and we multiply it by the probability of success. That's it. So much easier than what we have to do with a discrete probability distribution that is not a binomial. The standard deviation is also much easier, way easier than for a non-binomial discrete probability distribution. That is sigma, which equals the square root of n, I'm going to finish the square root symbol, times p times 1 minus p. Sometimes you will see this written as sigma equals the square root of npq, where q is 1 minus p. I don't tend to do that. Our textbook doesn't really do that. But some places you will see anytime 1 minus p is written, you will see it as q. But we can just go ahead and do np 1 minus p, multiply all those together, and then take the square root. So let's go ahead and do an example. So if a seed is planted, it has a 60% chance of growing into a healthy plant. You plant 10 seeds, keep them under the same conditions, and then record the number of healthy plants that grow. So I'm going to come up, I want to make sure I'm consistent with the colors that I was using. Okay, so 60% chance of growing into a healthy plant. That's our probability of success. That's our P. And then you are going to plant 10 seeds. I already forgot what color I used for N. You plant 10 seeds, so that's our N. N equals 10. And then we don't actually have X in any of these formulas, so we don't need it yet. We will need it later, so that's why I went ahead and introduced it already, but we don't actually need it yet. So to find the mean, I'm going to take my N and I'm going to multiply it by my P. Now we can't do math with percentages, so I'm going to turn 60% into a decimal, which is 0.6. 10 times 0.6 is 6. So the mean number of plants that grow is 6, or on average, 6 plants grow. And now we can do the standard deviation. That is sigma. And we're going to do the square root. And again, I'll finish the top piece here in a second. 10 times 0.6. I'm going to use parentheses for multiplication here because I have to for the 1 minus 0.6. If you have a scientific calculator, you can do this all at once. So square root 10 parentheses 0.6 close parentheses open parentheses 1 minus 0.6 close parentheses enter. I don't have to do any of the steps separate. And that is 1.5492. And that is how we calculate the mean and the standard deviation of a binomial.